Okay, so welcome back for video 2 of this lesson, and it's gonna kind of round out the properties of distribution. So when we see something like this, where we have just an expression in parentheses with a negative sign on the outside of it, what we've got to think of this negative sign as is we've got to treat it like a -1 to distribute through our parentheses, through our expression. So when I distribute, essentially all -1 does is it changes the sign of each of these terms, okay? So what these terms become, this becomes -2y plus 3x. And if it helps, rewrite all your subtractions as plus and negative. That's fine. That's a good idea, okay? So essentially, when you have a negative sign outside of a parentheses like this, treat it like multiplying by -1. So right off the bat, I know I only went through one example here, but I think you guys can handle distributing through. Just think of it as -1. So pause the video, work through these, and then check your answers with me when you're done. Okay, so pretty quick turnaround on this one. When we think about this, think of those as each being -1s to distribute through. So a plus 5 becomes -a minus 5. -x plus 31 becomes x minus 31. 4x minus 12 becomes -4x plus 12. So just changing the sign of each term that way. 6m minus 9n becomes -6m plus 9n. All right, so moving on. Finding the cost of 8 sandwiches using mental math, all right? So this is one, obviously, you're at Subway, whatever, and you're buying stuff, and you want to figure out the cost of a bunch of them. You could use a calculator. That's fine. There's no shame in that. But it's nice to have some strategies for doing some mental math, to at least be able to estimate or find out what's close. So when I look at a problem like this, I think about, I have 8 sandwiches. They cost $4.95 each. A simple way of thinking of this, you could think the cost of sandwiches, if they were $5, would be easier math, right? So when I think about this, I think about this in terms of $5 a sandwich minus 5 cents for each sandwich. So when I think about this using distribution, I could think about 8 times $5 a sandwich minus 5 cents off of each sandwich to kind of do a little bit of mental math. And again, this is just a strategy. This is not something that you need to memorize or anything. It's just a strategy. So if I'm going to distribute, this would be $40 if it was $5 a sandwich, but it would be minus that 5 cents a sandwich. So minus 40 cents. So the sandwiches would really cost $39.60. Again, not 600 cents, sorry. 60 cents, write that better. So when you think about it, should make a little bit of sense. Now, that's a mental math strategy. That's not something that everybody is going to use all the time, all right? Again, you guys have calculators right in your phones. Nothing's going to stop you from using them, but it's nice just to have some tools to do mental math, okay? So next, we are going to talk about like terms. And this is an important concept for later on. We use it a lot in Algebra 2 also. So, some examples of like terms are expressions that have the same variables raised to the same powers. So examples of like terms, 2y and -4y. They both have the variable y. Y is being raised to the same power, it's just y. 8w squared, -9w squared. They both have w, and w is being raised to the second power, okay? So same variable, same power. Some non-examples, 3w, -3w, and 6y. Different variables. 2w to the 4th, 2w to the 3rd. Same variable, different power. Okay, so that's why those aren't like terms. They have different powers. So some examples of combining like terms, 8x squared, 2x squared. Same variable, same power. And I just think I'm adding the coefficients of numbers on the front, 8 and 2. 8 plus 2 is 10. And then the variable and the power is unaffected. It's still x squared, so 10x squared. Now in part B, I'm going to pick out my like terms. I'm going to look at 5x. A like term with 5x would be -3x, which would become, sorry, getting ahead of myself, that would be 2x. Okay? And I'll use a different color. Negative 3 doesn't have a variable, so it can be combined with the other term that doesn't have a variable, positive 4. Negative 3 plus 4 is positive 1, so plus 1. And then I think, poor 6y doesn't have any like terms. Well, that's all right. It remains unchanged if it doesn't have any like terms. So this is simplified. I can't combine any of these terms any further because they're not like terms. Okay? So when we simplify expressions, we've got to be okay with getting multiple, numbers or terms in our answer, in our simplified answer. Okay? So look for the same variable with the same power. So they got it. Work through these, see if you can answer them, and then check with me once you're finished. All right, so to explain these, looking at the first example here, first problem here, 3y minus 2y, those are like terms. Y and y are like terms. So when we look at this, this is like 3y minus 1y. So 3 minus 1 is 2, so this becomes 2y. Next one, mn to the fourth. These are like terms. They both terms have the same variables, and those variables are being raised to the same powers. M, n to the fourth. So those are identical, so I can combine those. Negative 7 plus negative 5 is negative 12. And that variable and that power, variables and power stay the same. Just these numbers on the front, these coefficients as we call them, stay the same, or change, sorry. The variables and the powers remain the same. The coefficients and numbers on the front are what we're changing. Moving down, this one's a little tricky because we have same variables, but we have different powers. So 7y to the third z and y to the third z, those would be like terms, all right? And 6yz to the third, you'd think, yeah, they have the same variables and they both have a third power, but y is not being raised to the third power there. So that's why negative 6y z to the third is not considered a like term, all right? That's a little tricky, but that's a good one to show, all right? And then again, 7 plus 1. So if there's no number on the front here, we assume that this number right here is 1, okay? And then the last example here, can we simplify this any further? No, we can't. There are no like terms there. We have an x squared, x to the fourth, x, 2, and then an xy. There are no like terms. You would leave that. If I gave you a problem like that, and I said simplify, you would throw it right back at me and say, hey, I can't simplify this. It's already simplified. So just be aware of that. I may throw one at you that can't be simplified just to see if you can tell that there aren't any like terms. So be aware of that, all right? So now I think you guys are ready for the practice, all right? Work through that carefully, get ready for the checkpoint, and then be prepared, depending on where you're at or what day of the week it is before our test, that I'm probably going to end up giving you some sort of review material and maybe some enrichment if you're pretty far ahead. Now, we're going to have a class review session together, but you're still going to get review materials to work on, before our review and test day, okay, of Unit 1. And I'll go through those in class and kind of explain those a little bit further because this is our first unit test. So I really want to make sure you guys are prepared, you have a good chance to succeed on it, and that you guys give me feedback too on how things go, how the whole process is going. So I'm probably going to give you some sort of reflection as well in addition for this unit. So you guys kind of reevaluate and give me some pointers, give me some constructive criticism on how you're understanding and how these lessons are working for you, all right?